The last thing in this chapter is identifying what type of conic section you have when given an equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now I know that looks like a lot of stuff, but a, b, c, d, e, and f are just integers, positive or negative whole numbers. And we can tell a lot of things by looking at a couple things about these formulas. Over here with this example, the a value is -2. The b value is not 7. The b value is 0, so I don't have a bxy term anywhere. The c value is 7. The d value is -3. The sign matters, -3. The e value is 1. And the f value is not 15. The f value is -15. Because these have to be equal to 0. And right now I'd have to subtract a 15 from both sides to make that equal 0. I'm going to show a really simple way to find if it's a parabola, hyperbola, ellipse, or circle. The book's way is the good mathematical way, but we are never going to be graphing anything with the bxy term. We aren't going to see that at all, because the bxy is what takes a regular ellipse and turns it into a diagonal ellipse, or whatever. And we aren't doing it at that eccentricity. So instead, I made this pretty little flowchart. And you ask yourself some questions when you start. For example, we'll do this equation over here. Are both x and y squared? Well, yes. There's a square there, and there's a square there. So that's a yes. So we go to, does a equal c? Well, my a value is 3, and my b value, or my c value is 3, and that's a yes. So we know that this over here is a circle. We could do the same thing on the previous problem. If I copy and paste this, where's my cut button? This. Here, I can follow the same path. We'll do it green this time. Are both x and y squared? Yes. So we're here. Does a equal c? No. A is -2 and b is 7. So that's a no. Do a and c have the same sign? This one is negative. This one is positive. That's what I mean by sign, positive, negative. That's also a no. So this over here is a hyperbola. That's all you got to do to tell what type of conic you're working with, to tell what is what. So now we can just simplify these incomplete squares to find the equation of them. I already knew this one up here was a circle, and by completing the square twice, I can actually find the equation of the circle. It is, in general, x minus h squared plus y minus k squared equals r squared. So I'm going to make this equation I have look like that purple one. So I'm going to group out the x's and the y's. When I do that, I'm going to factor out the 3. Let me do that first. Factor out the 3 from the x's. Grab those two. And I'm going to factor out the 3 from the y's. So I just grab those two, and I'm going to move that 5 over. I just subtracted 5 from both sides. Well, over here I have -4. -4 divided by 2 is -2, and -2 squared is 4, so I'm adding a 4 here. But it's really like I added a 12. And over here, 6 divided by 2 is 3. 3 squared is 9, so I'm going to put a 9 here, but it's really like I'm adding a 27. And if I factor the left side, I have 3 times x minus 2 squared. If I factor the right side, it's 3 times y plus 3 squared, and that all equals 34. Now, for this to be an equation of a circle, I can't have these 3's, these coefficients. I'm going to divide everything by 3. And I get x minus 2 squared plus y plus 3 squared equals 34 over 3, and that's the equation of my circle. I didn't ask you to graph it, but if I did, the center would be at 2, -3, and the radius would be whatever 34 thirds is as a square root, whatever the square root of 34 thirds is. Okay, if I go through this process for this problem, I'm going to go through my flowchart again. I'm going to find if this is what type of conic it is. Circle, parabola, ellipse, hyperbola. Are both x and y squared? Yes. Does a equal b? No. A is 4, b is -6. Do a and b have the same sign? No. This is a hyperbola. I know it's a hyperbola. And I know that in general, hyperbolas look like this. Always equal to 1, and sorry, that's supposed to be a minus there. Not a plus, but it's a minus. Now, I don't know if this hyperbola is going to be an x coming first or a y coming first. I don't know if it's horizontal or vertical. So this could be switched. I could potentially switch around that x and that y, the x minus h and the y minus k. I don't know, we'll find out when I get there. Complete my square a couple times, so I'm going to have 4 times x squared plus 2x minus 6 times y squared minus 6y equals -22. Here, 2 divided by 2 is 1, and 1 squared is 1, so I added a 1, but I really added a 4. Here, 3, -6 divided by 2 is -3, and -3 squared is 9, but I really subtracted a 54 because -6 times +9 is -54. And that's going to give me 4 times x plus 1 squared minus 6 times y minus 3 squared, and that equals -72. Hyperbolas, I know, are equal to 1. Same with ellipses. Hyperbolas and ellipses are always equal to 1. So we're going to divide everything by that -72. That'll make the whole right side equal to 1. Well, 4 divided by -72 is going to be negative. I have x plus 1 squared on top. And the bottom is going to simplify to 18. -6 divided by -72 is going to be a positive 1 over 12 with a y minus 3 squared on top. And that's equal to 1. I don't want to have this little negative coming first. I don't like having that and having a positive here. So then I can't really tell it's a hyperbola. So I'm just going to switch the order that these two things come in. Y minus 3 squared over 12 minus x plus 1 squared over 18, and that equals 1. That's the equation of my hyperbola. The center would be at -1, 3. I would travel up and down root 12 units and left and right root 18 units. And then this is going to be a hyperbola that opens up and down. I know that because the y value came first, because that came first. Now I know that's not how this one looked. This one looked like an x minus h when I started, and that's not how it ended. That's because I just drew that up there to give me an idea of how I wanted this to finish, without actually knowing how it's going to finish. So that takes care of that. Hope that was helpful. Goodbye.